of 15 minus the same expected return I squared, I multiply by the probability 0.3. You get my answer there. Another one is 16 minus 14.5 squared multiplied by the probability, which is 0.5. So whatever you will get there is what we refer as variance. And then So we were doing the capital budgeting. I know we have not finished that capital budgeting, but we recover the other part to keep a revision. So let me introduce a new topic. There's some few concepts which we left on capital budgeting, and it was tested last sitting. So probably the sitting will not be tested on that, but we will not left it out again. We will have to look at it. Let's get now expected for this. We have the two weights. So which now, so our ERP, we want to do a new topic called the return for X is 16. We multiply by the weight 0.3 plus the return of Y times the weight of Y 0.7. That one will give us the expected return. So 16 times 0.3 plus 31 times 0.7. Portfolio analysis or getting the investment 91.6. You write portfolio analysis or the 91.6. That is expected return. That is number 5. Number 6. Number 6 is the standard deviation portfolio theory. Of the portfolio theory with the above weight and analysis with the above weight. Portfolio theory and analysis. Portfolio theory and analysis. So when we talk of portfolio, so the standard deviation of the portfolio, but this investment is several with the above. Maybe you have investment A, you have investment B, so you have investment let's C. Get that. So when you combine all of them, then we call it a portfolio. When you combine all of them, we call it a portfolio. Call it a portfolio. So let's write a definition and say a portfolio is a collection of investment. The formula of getting the standard deviation of the portfolio is the root of a collection. The root of, you take the weight is a collection of investments. You take the weight of X or assets squared, you multiply by the standard of X, the collection of investments or assets of Y squared. And then we also need to talk about the Y squared. The investor, who is an investor in this of X and so Y. An investor is a person who invests in this of X and Y. Person, two covariants of X and Y. So that is the formula. Venture. That is the formula of getting the standard deviation. Now you have the weight of X, which is 0.3 squared. We multiply by this standard deviation investment or this investment plus now 0.7 squared ukifanya investment squared. When you are doing the investment, what's the covariance of doing an investment of this? The main aim is to get the return or the profit. The main aim 515. Remember 517 was our or the profit. So get the standard deviation. If you are expecting to get the standard deviation, get every business they have a risk. So all these portfolio, each and every portfolio has its risk. So the reason of this topic is to calculate that you will get there. I will not do that for you because this one is just putting the calculator. Just so the main calculator. So that is about calculating the risk. So we can define the business portfolio. Also, what is this? I think before business risk, let's introduce other theories then here. Say before we look at the fluctuation. Refer the illustration to the fluctuation. The fluctuation. So or refer to the fluctuation. The illustration first. Go to the last sitting paper of cost. Go to the last of cost of sales. Cost of sales is cost of sales, and then or earning cost of sales or earnings. Then another point you say business risk. Business risk have been categorized. Into two. Has been categorized into two. Number one, we have what is called systematic risk. Systematic risk. Systematic risk. Systematic risk. So let's define this and say it is the risk that cuts across all the business. Umeshaandika huku, I hope umeshaandika that. Say it is the risk. It is the risk. That public financial advanced cuts across management. All the business. Advanced public financial management. It is the risk that cuts across all the business. It is the risk that cuts across all the business. So that is the definition of the systematic risk. That is the definition of the systematic risk. So when we say the risk which cuts across all the business, it affects all the investment. For example, a flood, or currently we are seeing a lot of war in Israel. So those are the kind of the risk which affect every called APFM, whether it's a service industry business, whether it is a manufacturing industry, it affects all the business. And a good example also is a flood. If there's any flood, it affects all the business. And then we have another one called unsystematic risk. Number two. So this was the last sitting paper, December 2024. Unsystematic risk. We have and say B. It is the risk. We have not covered, but the risk. That is our next. It is the risk topic. Question B, we have been told the beta one is that an investor at the security exchange intend to construct the minimum variance portfolio comprising the specific business companies, Simple Limited. It is the risk that affects the specific projected return. A good example is if you have a company and the economic high employee turnover, the state of economy, the risk to the company, and it's only affecting that probabilities. Not every business. So that's why we call it unsystematic risk. Number one, to have been told risk. That's why we call it the weight of the two companies shares in the minimum variance portfolio. Number two, so the expected return for the minimum variance portfolio, and also you will standard deviation for the minimum variance portfolio. So NB, the expected return for the minimum for this variance portfolio. Variance portfolio. This one it can't. So have you got it can be download that reduce? It can be reduced by a portfolio. It can be reduced by portfolio. It can be reduced by portfolio because if the risk here is the high employee turnover, we can. So it is asking for maybe in company A there's high employee turnover. In another company there's low employee turnover. For the weight. And also you can minimize this one. You can manage. But for systematic risk, you cannot reduce by the portfolio because it affects everywhere. It affects everywhere. So we have been told that this is December 2024 question. Question 2B. So number one is asking for weight of the two projects. The weight of the two projects, and we cannot draw this. We cannot get the weight until we get the normal return of this project, because the formula of getting weight, if you have not been given the weight, then you take the. So we have this project. This is a company, Simpa and Nyati. So we can use S and N. So for us now to get maybe the weight of S, we will take the standard deviation of N, which is Nyati company. We subtract the covariance of that S and N, which is the two companies, and then we divide. Make sure to square this. Let's square that. We divide by the standard deviation squared of N of N. You might not N. S. Take S. Are you done? And then also the standard deviation of square of N you minus by the two covariants. So we have to need to know exam focus. Actually, If you have you need to know exam focus, it is making that variance the which the subject of the formula. If you have that the standard deviation or the expected standard deviation of the portfolio. So this is our formula of getting the weight. So now we don't have the covariance, we don't have the standard deviation. So first we need to get the covariance and the standard deviation of the examiner is asking so about get the expected examiner will focus on expected return simple and also for security of the portfolio. Expected return for security of the portfolio. That's where the examiner will go to test most. That's the expected return. We have been given the probability expected return 0.3 of the portfolio. So we take for which the state of the portfolio. Nature, so make sure that you don't forget normal how to calculate the expected return. And we decision that when we were doing the probability for boom is 0.3 times 18 on how to get the expected return. Expected return. So the examiner here for recession example 0.45. We multiply by is the expected in. And then the other one return 0.25 or what? 0.25. We multiply by 9. How to calculate the expected return of the portfolio. You also need to know about the standard deviation, normal standard deviation, and recession. Standard. The probability remains the same. Also, examiner will ask you about the performance. 25. Multiply by the return. Appraisal. Multiply by the return of 10, 14, 15. Appraisal. We have some methods. 10, we have 14, some methods which we use to evaluate these performance. So let's get the appraisal. Performance appraisal. Let's get the returns. Performance appraisal. Let's get the return. Performance appraisal. How do we calculate the expected return? Leave alone to the portfolio. How do we calculate the expected return? We did this one. We said maybe just a reminder that we will not do an illustration because we did this one. We said expected return, you take the return, the total x, you multiply by the probability all of that x, I'm getting get what 7.8 return for expected return. And then so standard deviation is the root of what? Of the variance. Is the root of variance. I hope we said that. And we say for us to get the variance, no, that is for us to get the variance. So it should be 14, the sum of 85, the return minus the expected return of that x. You do what? You squared and multiply by the probability. And multiply by the probability. So that's how to get the variance. This one is how to get 15.1 and this how to get I'm getting 15.1 because so those are the standard the expected return. You will apply this standard deviation. You will apply this by getting the variance. Then maybe something the covariance. We don't need. Do we need the standard deviation? Yes, we need the standard deviation. The CV. So the return. But now here we will be need to know the covariance. 14.8 right their covariance. Multiply by 0.3 between maybe x and the next and is y. 16 covariance between maybe project x and y. So what is the covariance? You say covariance is the shared variation. Covariance is the shared variation. Is the shared variation or the variance. It is the shared variance. It is the shared variance. And then also you need to know the correlation. You need to know how to do the correlation.
I'm getting
correlation. You also need to know how to do the correlation. So correlation is just the correlation of the two projects. Correlation of the two project or the investment. So how do we get now the correlation? Covariance. It is the same. What is the now? So this is the variance, and this one you are saying covariance. So we are combining two projects. Maybe I think the best way is we have an illustration so that you can easily understand all this. Yes. 13.3. So write exercise or exercise 1. Exercise 1. 13.3. Exercise 1. Write the project.
21.3.
write the.
So is wrong.
We have the project. Let's have the
Take
0.3, 0.2,
0.3,
0.5,
0.3
and then we have return
10,
which is 3 plus 0.45
in
times
percentage.
Return there in percentage. Return x
Plus
plus
0.25 times
10,
16.
15, 20, 25,
Getting
30, and then 35. Required number
So
one.
when I check,
Number one, this is not 16. Return. Number one, expected return. Number two is 10. Standard deviation. So this one is coming to number 3. Number 3, the covariance.
13.3.
So let's get the variance. And number 4, correlation. Number 4, correlation. Number 4, the correlation. Number 4, the correlation. Number 4, the correlation. Tuko pamoja? Tuende na hiyo speed.
18.4.
EFM is a white topic. That's why we have to. Kiona nikienda haraka. Itabidi tu adapt your speed.
And round off this one.
Now, for us to get the expected return of x and y, we will take the probabilities. We check the probability 0.3. We multiply by the return. Then we add this probability times the return of 15 plus 0.5 times 20. That's what will give us the expected return of x. What about y? So we take the same probabilities times the 25 plus 0.2 times 25. Not this is 30 plus 0.5 times 35. That's what will give us the expected return of y. So put the calculator. 0.3 times 10 plus 0.2 times 15 plus 0.5 times 20. The first one I'm getting as 16. This one I'm getting that one. So now we have the the expected return. Number 2, the standard deviation.
So now we have
we cannot get the standard deviation before we get the variance.
That is not our case.
Then you need to use the expected return for return,
but
x, and for return
we can get
y.
the standard deviation.
So for return x, the standard deviation of the expected, we take the return of the variance, which is 12 minus 14. The return 6. Nyati is multiplied by the probability, which is 5.31 squared. Go the same.
That you can have the standard deviation.
15 minus 16.
So get the square root of 12.1
by 0.2.
This one is 3.2.
Another one, 20 minus 16 squared. We multiply by 0.8.
We say we take 2
then we come to the expected return of this one. Y is 2.8. Return of 0. Get
Y.
the covariance. Now let's get the covariance of the y, which now we have to combine. So this is our standard deviation. So let's get the covariance. Return 25 minus expected return that covariance squared multiplied by 0.3. Let's get the covariance minus 31 squared multiplied by 0.2. 35 minus 31 squared multiplied by 0.25. So how much is this?
You 16 minus. You can put in bracket. Open the bracket with the calculator.
Minus 16 plus squared multiplied by 0.3. So I'm getting 10. 8. We have 18.
15 minus 16 squared.
18 minus. What was the expected return? This one is 0.2. What was the expected return for Simba?
14.85.
14.85. And then take the first return for Nyati, which is 10, minus the return, which is 13.3. I remember that, squared, multiply by the probability, 0.3. So whatever you get here, you square. You don't square all of this. And then the next is for normal. For normal, we have 16 and 14. So take 16 minus 14.85. Then 14 minus 13.3 squared, multiplied by 0.45. Another one is 9 and 16. 9 minus 14.85, giving us the same. Into which same problem. We are getting the same covariance, the variance. So square root of the two. So that one will give us the covariance. Standard deviation. That one will give us the covariance. That one will give us the covariance. 4.36. The same case with this 4.36. That is the square. That is the square root. That is the square root. Put in the calculator. That is the square root. Go too fast. I go too fast. The first one I'm getting 48.63. Wapi hujalewa? Kindly confirm. Don't copy my values. Copy my values at your own risk. Tumesema expected return, you check the returns times the probability. You add. Also that one because you're gonna project X, but 0.29 of economics, which is or the state of nature, you're gonna 1, 2, 3. So this plus this time is this plus this time is this plus this time is this. You get the expected return of X. The same with Y. Then for variance, remember the formula of variance. We said you take the return minus the expected return, you square, you multiply by the probabilities. Whatever you get for the 3, you sum. After getting the sum, get the square root so that you can get the standard deviation. The standard deviation, so that you can get the standard deviation. 62.37. Let's confirm this one. 9 minus 14.8 multiplied by 16 minus 13.3 squared multiplied. So kindly let me know if you have written. We do the covariance. Good. So for covariance, so that is the covariance. So now let's get the weights. Let's get the weight of n. Covariance of x, the weight of n and y will be the standard deviation of shared which is a shared variance. It is a shared variance. So the covariance, take the variance, you take the return for x, divide. Kwanza unamalizana na 8, which is 8 minus the expected return, the same value of that, which is 16. And then since it is a shared variance, since this one is a shared variance, you will combine the first state of y, which is 25, minus the expected return, that 1, you squared. And then you multiply by the first probability, which is 0.3. You go to the second one, which is 15 minus 16. The correct one. 30 minus 31. Take the standard deviation, multiply by the second probability, squared, multiply that. Number 2, 3 squared. Or number 3 is 20 minus 16. 29. And then combine with that 5 minus that 1. Let's get past multiply by the last probability. At the top, that one will give you 0 what is called the covariance. 11.29. You get the covariance. Getting so negative. We combine the 2. 6, we divide by the 2. 3.48 squared. So let's get the covariance. You can put the calculator. Squared. Open the bracket. 16 minus 10 minus 16. Close the bracket. Open the bracket. 25 minus 31. Close the bracket. Whatever you get. This one I'm getting negative. Squared. 150 multiplied by 0.52. So I'm getting so here. Negative and negative will cancel each out. 8, up 106 we divide by. Come to this. 158. Open the bracket 15 minus 16. So our the bracket open the bracket 30 minus 31 is 0. The bracket answered squared 7 multiplied by 0.67. This I'm getting that is weight of. The other one, weight of N. 20 minus 16. Now we have been told that close the bracket, open the bracket. Weight should be equal to 1. Close the bracket. 1. So for weight of squared, multiply by 1 minus 5. You're getting 120. So weight of 8. Let's get the sum. 388 1 minus 0.072 plus which is 0.8 128. I'm getting 50. 0.317. So that is the first part of that question. That is the covariance. That is the first covariance. And then we have what is called the correlation. Correlation. We go to the second correlation between the two projects, which is X and Y. Between X and Y. Between X and Y. So that I know needs to move to the next step. So how do we get the correlation? So the formula of getting the correlation of
I'm not able to see the last part.
Correlation to the symbol of correlation. Last part you'll be using R. Using R to symbolize the correlation. So nitachukua R XY equals to, you take the covariance covariance that gotten divide by half part divide by 0 standard deviation and the other one is standard deviation of 8 and standard deviation of cancel the negative. If you divide that, it's coming to and the standard deviation of, so that is the weight Y of W. So write that Nyati, which for us to get for S, take 1 minus that to get 0.33. So now we have answered to that question for weights. So let's go to the second part, asking for the expected return of the portfolio. The expected return of the portfolio. So now the key thing when it comes to the financial management is to write the formula first. If you see any question, write the formula. That one will guide you to know, do I really have all the variable? Do I really have all the variable? So the expected return of the portfolio, we said the root of weight of S, which is simple. We have already gotten this. By covariance is the root of the weight of 117. 517 we divide by the standard deviation. Before we that we said you take the standard deviation of S squared 19 multiplied by N squared 4.36 squared 4.36 you multiply by 4. Standard deviation squared 4.36. So add 4.36. We add get 19 and then 517 we divide by answer. So the correlation here is 27. Already we have this. We have everything. We have everything. Which is more than everything. And anything which is more than 1 is very everything. So we have weight. The relationship is so strong. 0.3. Relationship is so strong. I can start here. The relationship is so strong. 0.3 is so strong. So having done that, we can continue with the same illustration. 3. Continue with the same illustration. We get the expected return of the portfolio. We need to get to know the expected return of the portfolio. This one is 3. The expected return of the portfolio squared So having done the correlation, the next is you need to know how to get the expected return of the two covariant. You have already got remember the normal expected return, and then whatever you get here, do the square root. Expected return of get portfolio. This one, when we add the portfolio, we will learn to introduce what is called the weight. We need to have the weight. So number hiyo ilikuwa namba ngapi? 1, 2. Now that one is the standard deviation. Number 5. Number 5. That is the standard deviation of the portfolio. Expected. I think this one is for Roman 3. Roman 2 of this is the portfolio. Roman 2 we have this one to write this of the portfolio. Assuming the weight of X, standard deviation, then expected return. We say we take the weight of S, we multiply by the return of X. The return of that is S 0.3. Return of assuming the weight of X is 0.3. Multiply by the weight of X is so weight 0.33. Assuming the weight of X is 0.3. Now, how do we get the expected return of the portfolio? How do we get the expected return? ERP. That one the answer now. Expected return ilikuwa ngapi? You take the weight of X. The weight of X, which we in this case we can
14.85.
We multiply by the return of 8.85. We multiply by the return of X. The weight is 6.7. The weight of Y is 13.3. The return so that one you will answer. This one is for return of Y. We have been given the weight. So we have done to that. We have been given the weight of X. So the weight always equals to 1. The weight equals to 1, which is the weight X plus the weight of Y. So is equivalent to let's 1. Get now expected for this. We have the two weights, which now, so our ERP. So we were doing the return for X, the capital budgeting. I know we have by the weight 0.3 capital budgeting plus the return of Y times the weight of Y. Cover the other part 0.7. That one will give us a revision. The expected. So let me introduce a new topic. 16 times 0.3. There's some few concepts which we left on capital budgeting. 31 plus 7. So probably the sitting will not get 90 on that. 91.6. But we will not left it out again. We will have to 91.6. That is part of the revision. Expected return. So that is number 5. Number 6, we want to do a new topic called portfolio. The standard deviation of the portfolio analysis or the investment. You write portfolio analysis or the investment with the above weight. So the standard deviation of the portfolio with the above weight, for portfolio theory. Portfolio theory. Let's get that standard deviation and analysis. Portfolio theory and analysis. Portfolio theory and analysis. So when we talk of portfolio, we need to get the formula of we are talking of an investment. But this investment standard several investment. Maybe you have investment A, you have investment B, you have investment C. So when you combine all of them, then we call it a portfolio. Check the weight of X. All of them, we call it a portfolio. You multiply by the standard of X squared plus. So let's write a definition and say a portfolio is a collection of investment. By the standard of Y squared. Portfolio and two covariants of X and Y. Is a collection of investment X and Y. Two covariants of or assets. Y. So that is the formula. Assets is a collection that of the formula of or assets. And then we also need to talk about now we have the weight of X, which is 0.3, who is an investor in this type standard deviation. So an investor is a person who invests in 0.7 squared multiplied by 19 squared. The person O plus the covariance, the two covariance of venture. We add the covariance, so 2 in what multiplied by the portfolios. 515. Remember 517 was our or these our covariance investment so or this investment. Now get the standard deviation. Ukifanya investment,
get the standard
when
deviation.
you are doing the investment, what is the aim of doing an investment?
Get
The main aim is to
deviation.
get the return or the profit.
Get to the standard
aim.
deviation.
So whatever you will get there, I will not do that for you because
or
this
the
one
profit.
is just putting the calculator. So if you are expecting to get the return,
so that is a first part of
every business they has a risk. So
portfolio.
All these portfolio, each and every portfolio has its risk.
Let's introduce.
So the reason of this topic is to calculate that risk attached to that portfolio or attached to that investment.
Illustration.
So the main reason for this topic is about calculating the risk.
Illustration part.
So we can define the business risk also. What is this?
The last sitting paper.
Business risk.
That is A.
Then to say, refer to the fluctuation. Refer to the fluctuation or changes. The fluctuation. Refer to the fluctuation of cost of cost of sales, and then or earning, cost of sales or earnings. Then another point you say business risk. Business risk have been categorized. Into two. Has been categorized into two. Number one, we have what is called systematic risk. Systematic risk. So let's define this and say it is the risk that cuts across all the business.
Financial management.
Umeshaandika huku, I hope umeshaandika that. Say it is the risk. It is the risk that cuts across all the business.
I doubt.
In APFM. That
Do you have a unit called
APFM? It is the risk that cuts across all the business. So that is the definition of the systematic risk.
Do we have a unit called
APFM? Of the systematic risk. So when we say the risk which cuts across all the business, it affects all the investment. For example, tukipata a flood, or currently we are seeing a lot of war in Israel. So those are the
kind of the last
risk which affect every business, whether it's a service industry business, whether it's a manufacturing industry. It affects all the business. And a good example also is a flood.
Topic. Question B, you have been told the beta Mwangi,
all the business.
An investor at the security
we have another one called
intend to construct the minimum variance portfolio. Number two, comprising the shares of two companies, Simple Limited and Nyati Limited. And systematic projected return on the shares of the two companies under the three different states of the economy are as follows. The state of economic, boom, normal, and
the risk that
probabilities, and the return specific percentage. Number one, to have been told
specific business
required the weight of the two companies.
It is the risk that affects the specific business. A good example is
the expected
you have a company
minimum variance portfolio,
employee
turnover deviation for the minimum
the risk
variance portfolio.
And it's only affecting
the
that
expected
business,
return for the minimum
not every business.
Variance portfolio.
That's what we call it.
Variance portfolio.
And systematic risk. That's what we call it.
Make sure to download that.
Ilisahau kukuandikia hapa. So NB for unsystematic, and also you will write the NP on systematic. So NB for this.
So we are.
So it is asking for this one. It can't the weight. It can be this weight reduced. So they are asking for the weight be reduced by a portfolio. It can be reduced by portfolio. It can be reduced by portfolio because if the risk here is the I
So we have been
employee
told
turnover.
that
We can,
this is December.
maybe in company A, there's I employee
2024
turnover.
question.
In another company, there's a low employee turnover. And also, you can minimize this
Question
one.
2B.
You can manage. But for systematic risk, you
So
cannot
number 1 is
reduce
asking
by
for weight
portfolio because it affects everywhere.
of the two projects.
So the weight of the two projects. So we cannot get the weight until we get the normal return of this project, because the formula of getting weight, if you have not been given the weight, then you take the. So we have this project. This is a company, Simpa and Nyati. So we can use S and N. So for us now to get maybe the weight of S, we will take the standard deviation of N, which is Nyati company. We subtract the covariance of that S and N, which is the two companies, and then we divide. Make sure to square this. Let's square that. We divide by the standard deviation squared of N of N. You might not N, S. Take S. And then also the standard deviation of squared of N you minus by the two covariants. The two, actually, if you have it is making that variance the weight, the subject of the formula. If you have that, the standard deviation or the expected standard deviation of the portfolio. So this is our formula of getting the weight. So now we don't have the covariance. So we need to know exam standard deviation. So first we need to get the covariant and the standard deviation of these two projects. So let's get the expected return first of project Simpa, and also for expected return for Nyati. Expected return for Nyati. Expected return for Nyati. We have been given the probabilities, 0.3. So exam forecast for which the examiner is asking about, or the examiner mainly focus on normal expected return and security of the portfolio. So the probability for boom is 0.3 times that's where the examiner will go to test most. 18. That is the expected return. Is 18. Expected return for recession is 0.45. Expected return of the multiply by 16. So make sure that you don't forget how to calculate the expected return. 0.25. We did that when we were doing the introduction. We multiply by 9 the introduction on how to get the expected return of expected return. So the examiner here or exam focus is this, and recession is the probability remain the same, 0.3, 0.45, expected return 0.25 or what by the portfolio. Multiply by the return of 10, how to calculate the expected return of the portfolio. 10, 14, you also need to know 15 about the standard deviation. So let's get the return. Standard deviation. Let's get the returns. The standard. Let's get the deviation. Examiner also will ask that. Also, examiner will ask you about the performance appraisal. Where is my calculator? Appraisal. We have some methods. We have some methods which we used to evaluate this performance appraisal. Performance appraisal. Performance appraisal. Performance appraisal. How do we calculate the total? If you put in the expected return, them expected return, leave alone the portfolio. How do we calculate the expected return? Seems so big. We did this one. Is it the same, really? We said maybe just a reminder that we will not do an illustration because we did this one. We said expected return. No, you take this is incorrect. Return, maybe so it will be 14 by the probability of that 85. You get what? Expected return. Expected return. And then we say standard deviation is the root of what? Of the variance. Is the root of variance. I hope we said that. And we say for us to get the variance, you take the sum of what? The return minus the expected return of that x. You do what? You squared and multiply by the correlation. So correlation is just the correlation of the two projects. The correlation what is the project or the investment. So how do we get now the correlation? Covariance, it is the same with this one. Now, because this is the variance and this one you are saying covariance. So we are combining two projects. Maybe I think 13.3.